Hello, hi, my name is Gift and this is Tectanum. Welcome to video 3 in the beginner to Arduino sessions, and in this session we're going to get into sensors. For this video we're going to handle the IR sensor. We're going to know what the IR sensor does, how it works. We're going to look at its pin diagram, how to connect the IR sensor to the Arduino board, and then we'll look at the code. We'll explain the code and we'll see the output of the IR sensor. Okay, so the IR sensor is a sensor that emits and detects infrared radiation. And infrared radiation, basically IR, is part of the electromagnetic spectrum, but its wavelength is really high and it's not visible. It's higher than visible light, so as for the human eye you cannot be able to see infrared light. So I'm going to take you to my screen so that you can be able to see the components on the IR sensor. So what we have here is the IR sensor, and we are going to discuss the components of this IR sensor. So first we have this here. This is our IR emitter. So this is what emits infrared. And this here is the IR receiver. So this emits light, IR light, and then this receives the IR light. So the working is in such a way that the emitter emits infrared. The light goes and hits an object. So say we have a wall here. So let's say we have an obstacle here. This is our obstacle. So this will emit light that will hit the obstacle, and then this will be reflected back to the IR. So the time that it takes for the light to travel from the emitter to the receiver is what is used to calculate the distance or the presence or absence of an obstacle. Okay, so if it takes a shorter time to come back, then it means there's an obstacle that's close by. Okay, so then there's this potentiometer here. This acts as a distance adjuster. So the distance adjuster, it changes the detection distance. So you could want it to detect objects that are really close, or you want it to detect objects that are further away. So dependent on the direction within which you turn your potentiometer using a screwdriver, you can be able to adjust the distance. Okay, then now we'll move on to the pins. So these are our pins, and as has been labeled, we have the VCC pin here, then we have a ground pin, and then we have an output pin. So the ground pin is connected to the ground of the Uno board. So if you look at what we had drawn here, we have ground pins here. So you connect, there are two ground pins here, so you can connect to either of these pins. And then the VCC, we connect to 5 volts. So 5 volts, you have your 5 volts here, and the output pin you connect to whatever digital input pin you want to connect it to. Okay, so just a little bit about how the IR sensor works. So when there's an obstacle, the IR transmitter emits the infrared radiation, right? And then the infrared radiation will hit the obstacle. Okay, and then the IR radiation should get reflected. Okay, so if the IR receiver detects radiation, then the resistance drops. So the signal output pin sends a low signal to the microcontroller. Okay, so similarly, if there is no obstacle, light is not reflected. So the IR transmitter will transmit a radiation, then the IR radiation will not get reflected. The IR receiver will not detect any radiation, and the output pin on the IR sensor will send a high to the microcontroller, a high signal. Also, an important thing to mention as well are these LEDs here and this LED here. So this LED will come on if there's an obstacle, and we'll see how that works. And this is the power. So when you plug this sensor to the power, then this will come on. So we can just say this is a power LED. Okay, so let's get into the connection of this sensor to your Arduino board, and with that I'm going to use a circuit diagram. So this is how it is connected to the Uno board. So this is our circuit board. We have our IR sensor here and our Uno board right here. So we have the signal output pin, we have the ground pin, and the VCC pin. So the VCC we've connected to 5 volts, as you can see here, and then the ground pin we've connected to one of the ground pins here, and then the output pin we have connected to digital input pin 2. Okay, so it's important to note where you've connected, especially for the digital pins, because that is what you will use in your code. Okay, so this circuit diagram will be available in the description box should you want to replicate this project. So after connecting it like this, I'm going to show you how I connected mine, and then we're going to power up the board, we'll upload the code, and we'll see how the sensor behaves. So now that we have powered the board, we have made the connections to the IR sensor and our board is on. Our board has been connected to our laptop, so we want to upload the code onto our microcontroller. So we'll go up here and upload our code. So the code does not have any errors. So just to go through the code, we have declared a variable IR sensor, and it is going to be connected to the Arduino pin 2. Remember, in our circuit diagram we had connected the IR sensor output pin to the digital input pin 2, so it has to be similar. If you put it on another pin, then it wouldn't work. And then onto our main code here, we have declared that this IR sensor variable is an input, and we are opening the serial port. This serial begin means opening the serial port, and this is the speed at which the data will be transmitted. And then we have the code that's under void loop is just another variable that we've declared, which is status sensors, and it's reading the value that will be from this variable that we have connected at pin 2. Okay, and if the status of this variable is a high, then it means that there is no obstacle detected. Remember when I explained, when there is no obstacle, when there is no reflection back, then the status is a high. And if the status is not a high, then it means there's an obstacle that has been detected, which is a low. We have set this code to wait for 2 seconds before it starts repeating itself all over again. So as we have compiled, we have seen that we have no errors in our sketch, but let me just show you an example of an error. So I've removed the semicolon there, and now I have an error. This line is highlighted in red, and down here on this dialog box, then you can see that the solution to the error they're saying is we should add a semicolon before the serial. So we come here, we add back the semicolon, and then this should be able to solve our error. So sometimes you might find an error that you are not familiar with or you have never encountered before. You have the option of copying the error. You have the option of copying the error message and then pasting it on your browser, and then you can be able to see that. So in the case where you have an error that you are not familiar with, you can just copy the error message right here, and then you can paste it on your browser, and then you can be able to Google and find a solution. Most of the solutions are available in Arduino forums. So if you just put in your error message or error code, it will be able to direct you to a few of these forums, and if you look keenly, you'll probably find someone who's experienced the same issue as you, and hence you'll be able to find the solution. So now that we've corrected our code, let us verify it one more time. It has compiled, our code is okay, and now we are going to upload it onto our controller. It is done uploading. So for us to see the output, we are going to open the serial monitor. There we go. It says there's an obstacle that has been detected. If I lift the sensor from the table, now there's no obstacle that has been detected. I'm moving my hand close to the sensor. Now it is able to detect an obstacle. If I move it away, it's detecting no obstacle. I move it right back in, it detects that there's an obstacle. Okay, so that's just basically how it works, right? So let us minimize the serial monitor. So that's it about the IR sensor. We've been able to see the pinout, we've been able to connect it, we've gone through the code for an IR sensor, we've uploaded it onto our microcontroller, and we've been able to visualize the output on the serial monitor. So for our next lesson, we are going to work with the ultrasonic sensor. The structure will be the same as for this lesson, so I'm looking forward to seeing you there. Thanks for watching. Please remember to like, share, and subscribe. I'll see you on the next one. Bye.